One of the fundamental pieces of military equipment is the infantryman and his rifle. Throughout the history of firearms, the soldier's musket was the crucial piece of hardware in gaining ground and holding it, effectively winning the battle. Despite advances in weapon ignition systems culminating in the percussion cap, all firearms suffered from the same drawback of muzzle loading. By the time of the percussion cap, most armies had modified their stock of flintlock rifles or purchased new percussion designs. Attempts had been made over the years to improve this situation, and many samples of breech-loading weapons exist. Henry VIII had a fine example of a pair of wheel-lock pistols that were breech-loading. Samples of wheel-lock and flintlock muskets with this unique system abound. One of the main reasons they were not successful was due to their cost, and often the escape of gases from the chamber made them sometimes less than reliable. One attempt involved a British designer, Frederick Prince. In 1855, his bolt-action design was manufactured. A bolt protruded from the barrel that allowed the entire barrel to be unlocked and slid forward, allowing access to the breech. Another design was the Ferguson rifle. The Ferguson rifle had a short but distinguished life. A half-turn threaded plug at the back of the barrel could be quickly removed and the weapon loaded, sealed and ready to fire with the conventional flintlock. 100 ordered and an infantry company formed that fought in America. Breech-loading designs proliferated. 1819 saw the United States the first country to adopt a breech-loading rifle as the principal infantry weapon, the M1819 Hall rifle. The rear breech could be raised up and charged with bullet and powder, then dropped into position ready to fire with a cap and percussion lock. A flintlock version was also manufactured. In 1812, Swiss gunmaker Samuel Johannes Pauli, who had served in the Swiss artillery, took out a patent on a new breech-loading mechanism. The brake-action mechanism was not new, but in combination with a new cartridge design was outstanding. The design incorporated a wooden or brass base with a recess in the center, where a cap or pellet was placed. The base was slightly tapered, as to the breech, allowing for a snug fit of the cartridge base. This sealed the chamber, keeping gases from escaping. Secured to the base was a paper tube, into which went powder and shot or ball. A firing pin was housed within the mechanism. In effect, Pauli had developed the first shotgun cartridge. Another avenue of development, led by J.N. von Dreyse, was the so-called needle gun. In 1827, the Dreyse breech loader was developed. A bolt was drawn back, revealing the breech. A special paper cartridge consisting of bullet, powder, and an igniter or fulminate cap set at the base of the bullet was inserted, and the breech closed with the bolt action. To fire, a spring-loaded needle would pierce the paper cartridge and strike the primer cap behind the bullet, firing the shot. It was so successful that the Prussian army adopted the weapon in 1840, and it saw active service in 3 consecutive wars against Denmark, Austria, and France. The needle gun had 2 drawbacks. One, the breech did not always seal correctly, allowing the escape of gas. And since the needle must reside inside the cartridge as it burns, the needle was subject to extreme heat and corrosion from the powder, often breaking or warping. However, the bolt action enabled riflemen to remain prone and concealed while reloading, a development not lost on the opposition, who also looked to adopting breech-loading technology. The British developed the Snyder rifle from the earlier Enfield rifled musket of 1853. It had better breech sealing, and the angled pin was less likely to fracture. The French developed the Chassepot rifle in 1866. It was an improved Dreyse design which included the automatic cocking of the firing pin as the bolt was closed. The modern all-metal cartridge was not far away. In 1855, a patent was taken out by Clément Potet for a cartridge with a metal base, a percussion cap set in the center resting against an anvil. A firing pin would strike the cap and crush it against the anvil, igniting the charge. The flame would enter the body through vent holes, firing the main charge. 3 years later, a similar design by François Schneider was purchased by British gunmaker George Daw and received a patent in 1861. At the Royal Woolwich Laboratory in London, Colonel Edward Boxer combined the Schneider-designed metal base and primer with a coiled brass body cartridge. The brass was flexible enough to expand and completely seal the breech as the powder burned. The year was 1866. It took another year before the process of constructing the entire case from one piece of brass was accomplished. But the breakthrough was made, and a rifleman could carry his ammunition in one complete unit, weatherproof and reliable. He could load his weapon with ease and could increase his rate of fire tenfold. Few realized at first what a leap forward the modern cartridge was, for it would allow the development of self-loading and eventually fully automatic weapons. The breech-loading rifle was quickly adapted to take the Boxer cartridge. The race was now on to fit the rifle with a supply of the new ammunition, a magazine to speed up the cyclic rate of loading and firing. Magazines were not a new idea. Many early designs going back to flintlock had been tried. One of the more successful was by Walter Hunt, a prolific inventor who also designed self-contained hollowed-out bullets with the powder charge sealed inside. He developed a 12-round tubular magazine and feed system he called the volitional repeater. The mechanism was too complex and flawed to be practical, but Lewis Jennings took over the design and in 1849 received a patent for his major alteration, which was to make it a lever-action mechanism. And this caught the eye of two American gunmakers, Daniel Wesson and Horace Smith. Smith and Wesson had teamed up in 1852 to produce the volcanic pistol. Their company was called the Volcanic Repeating Arms Company. They also took on the lever-action repeating rifle design. They met with limited success with the caseless ammunition. The company went bankrupt. A shirt manufacturer by the name of Oliver F. Winchester took over the company and renamed it the New Haven Arms Company. Dan Wesson set about designing a rimfire cartridge to solve their engineering problems. Benjamin Tyler Henry joined the company and quickly set about perfecting Wesson's rimfire bullet. He redesigned the volcanic lever action, retaining the tubular magazine and breech mechanism. The .44 caliber Henry rifle of 1860 was born. Never officially adopted by the Army, the Henry was ordered by many Union officers and soldiers during the American Civil War. The 16-round weapon was disdained by the Confederates, who were quoted as saying that damn Yankee rifle that they load on Sunday and shoot all week. Another rifle designed with the rimfire cartridge was the Spencer repeating rifle. Christopher Spencer based the design on the Dreise breech loader, with the tubular magazine in the butt of the rifle. After loading the breech with a lever action, the hammer had to be cocked manually. After an audience with President Lincoln, Spencer gave a demonstration, whereafter the gun was put into production and adopted by the Union Navy and Army. It saw action in the Civil War. After the war, Oliver Winchester renamed his business the Winchester Repeating Arms Company and set about redesigning Henry's rifle. The 1866 model Winchester lever-action rifle had numerous improvements, including the side-loading port and wooden forearm. It fired the same rimfire .44 caliber ammunition. The 1873 Winchester went on to become the gun that won the West. Chambered with a center-fire pistol cartridge, 4440 and other pistol calibers, it wasn't until the 1876 Centenary model that it was chambered for a full-powered rifle cartridge. Many more models of the popular Winchester lever action were produced, including the 1876, 1886, 1892 and 1894 models, each improving the design and increasing the caliber and accuracy. In 1871, the Martini Henry rifle was adopted by the British military. It was the first rifle designed from the ground up as a single-shot cartridge breech loader. It had a hinged block that would drop to expose the breech. It was actuated with a lever action that also cocked the internal firing pin. Several variants were also manufactured, particularly in the barrel rifling system and ammunition caliber. After the American Civil War, the US Army was left with a large quantity of muzzle-loading arms, particularly the Springfield 1863. To save costs, these were modified into breech-loading cartridge weapons, the Springfield Model 1873 trapdoor carbine. In 1884, the German army was the first major power to equip its foot soldiers with a magazine-fed rifle. They had modified their stockpile of 1871 Mausers into an 8-shot tubular magazine rifle. The bolt action was seen by most as the future of military firearms, and 3 distinct types of bolt action developed around the same time. Although there are other variants and modifications, the 3 principal types were the Mauser, the Lee-Enfield, and the Mosin-Nagant. The Mauser is the most common type of bolt action and was introduced in the German Gewehr in 1898. Its main difference is the mechanism is cocked on opening the breech, and it has 3 locking lugs. This system was also utilized in the American M19-3 Springfield, the Japanese Arisaka Type 38 and 99 rifles, and the M1917 Enfield. The Lee-Enfield, or originally Lee-Metford design, was introduced in 1888 with the Lee-Metford magazine rifle Mark I. This bolt has the difference of cocking on closing, allowing for a faster rate of fire, and a separate bolt head that does not rotate with the bolt and is removable. After several adaptations, the 1902 Short Magazine Lee-Enfield, or SMLE, was introduced to British and Commonwealth forces. Its variants and models saw active service for over 50 years, and it was considered one of the best bolt-action service rifles. The Mosin-Nagant bolt action, created in 1898, has a separate bolt head that rotates with the bolt body. More complicated than the other 2 types, but extremely rugged and durable. From bolt action, the next step was the self-loading rifle. There were several self-loading models appearing in industry circles from the turn of the century. Notably, Winchester produced several models from 1903 and 1905 through to 1907 and 1910 models. Remington were also in the game with their Model 8 self-loader and later versions. While the First World War in France had drawn to a stalemate, there arose a requirement to arm their pilots with a rifle capable of high rates of fire. The French Army purchased many Winchester 1907 and 1910 models. The need for a self-loader on the battlefield was also proven, and the French military set about developing a model of their own, and, as a stopgap, revived an earlier design by Etienne Meunier. It was chambered for a 7mm round and was rushed into production in several weapons plants as the Model 1916. The Fusil Automatique Modèle 1917 8mm self-loading rifle, which incorporated components from both earlier rifles and different manufacturing plants, was put into production in April 1917 and soon after issued to frontline troops. The US Army trialed several self-loading rifles of the time, including the 1911 Bang and Murphy Manning. John Garand, a talented weapon designer working for the Springfield Armory, worked on his own design for several years, producing numerous prototypes in various calibers. The Army had large stockpiles of .30 caliber ammunition and decided their new rifle should be chambered for this caliber. Several Garand-designed models were put to trial with the Army and Cavalry. Bugs ironed out, and a production model went into service. The M1 Garand officially replaced the bolt-action Springfield M19-3 of the US Army in 1936. Even after introduction, design changes were made in 1940. The gas-operated rotating bolt was fed with an 8-round clip as opposed to a separate box magazine. Once the last round of 8 was fired, the clip was ejected and the rifle's bolt remained open, ready to receive the next clip of ammunition. The method of loading was fast, simple and efficient. However, the one drawback was the familiar sound of the spent clip ejecting from the firearm with a ping, alerting the enemy that a reload was in progress. Whether this had any effect is debatable. During the war, Soviet designer Fedor Tokarev advanced his earlier designs for a self-loader and introduced the SVT-38. In use during the winter months, complaints about poor design surfaced, and it was reworked and dubbed the SVT-40 with several design improvements. It served out the war and was eventually replaced by the SKS and Kalashnikov rifles. The Russian-designed Samozaryadny Karabin Systemy Simonova, or SKS for short, was a semi-automatic carbine designed in 1945 to take the new ammunition caliber 7.62 by 39, beating out several other designs, including one by Mikhail Kalashnikov. China and East Germany adopted their own variants of the model. It was fed with a 10-round box magazine and was a short-stroke gas piston design with a tilting bolt. Kalashnikov had the last say, though. The SKS was quickly superseded by his AK-47 assault rifle. The SKS and its variants saw action on many fronts, including the Korean and Vietnam Wars. It exists today in a modernized civilian form with composite stock, high-capacity magazine, and scope rails. During the Second World War, the US military found they needed a new rifle that was self-loading, compact, and lightweight for use by paratroopers and frontline troops required to carry other equipment, such as mortar teams, signalers, even cooks and storemen. It needed to be more powerful and accurate than the submachine gun, but smaller than the Garand or BAR. And so Colt set about developing the M1 carbine. It saw service in the war and later in Korea and became a popular civilian weapon. It was chambered for a .30 caliber short round similar to a pistol round. The M2 variant had selective fire capability. It utilized the same rotating block and operating rod as the Garand and a short-stroke gas piston design. Magazine capacities were available in 15 and 30 round capacity. Over 6.2 million were manufactured for military use. Several manufacturers produced commercial versions for the public, and they are still available today. Soon after World War II, European nations began seeking a new self-loading rifle for general service. The British favoured an advanced bullpup design, the EM2, with a new caliber .280. However, political forces swayed this decision in favour of the US choice of NATO caliber and the Belgian-designed FN-FAL. Fabrique Nationale Fusil Automatique Légère, or FN-FAL, began development in 1947 and continued until 1953. The Belgian design was eventually chambered in the NATO 7.62 caliber and saw widespread acceptance as the ideal infantry rifle. There was competition from other designers, in particular the German Heckler & Koch G3. The SLR L1A1 self-loading rifle was adopted by many armies throughout Europe, the Commonwealth, Africa, and South America. It had an adjustable gas-operated system similar to the SVT-40. The gas vent could be adjusted to allow for blank cartridges or rifle grenades. It was fed by a box magazine varying from 5 to 30 rounds capacity. Many variants appeared, some with shorter barrel lengths, folding stocks, bipods, and even a fully automatic squad weapon. The weapon survives to this day in some quarters and as a popular hunting rifle variant. Regarded by many as one of the preeminent gun designers of the United States, along with John Browning and John Garand, Eugene Stoner began his working life in an aircraft factory, installing armaments in aircraft. He enlisted in the Marines and served in the Pacific and China during the Second World War. After the war, he became a design engineer and eventually joined the Armalite division of Fairchild Engine and Airplane Corporation. There, he designed several prototype small arms, including the AR-10. Chambered for the NATO ammunition 7.62 caliber, it was an unconventional lightweight design with a selective fire capability. Submitted for evaluations with the US Army in 1956, the design lost out to the T-44 model, an evolutionary development from the M1 Garand model, or M14 rifle, which was subsequently adopted by US forces from 1957 to 1966. However, due to the rifle's accuracy and stopping power at long range, several variants, particularly the sniper version, have remained in service with some branches of the US military. Eugene Stoner's AR-10 was licensed to a Dutch arms manufacturer and saw some success in several smaller countries. His advanced designs would have to wait some years before being adopted outright by his home country. In 1862, a patent was taken out for a gravity-fed box magazine gun with 6 barrels by a Dr. Richard Gatling. The weapon was a breakthrough in multi-barrel design, for each barrel incorporated its own breech and firing pin. Mechanically actuated by a rotating hand crank, the barrel assembly would rotate about a central axis. Each barrel in turn was loaded with a round from the overhead hopper, breech closed, firing pin primed, barrel fired, breech opened and spent shell extracted. Then the process started again. One advantage was the high rate of fire. The Gatling gun could discharge a shot, then allow the barrel to cool as it proceeded around the mechanism, unloading and reloading. The gun could fire up to 600 rounds a minute. The Gatling gun had many faults, and the US Army passed on it. However, Major General Butler purchased 12 units, and they saw limited service in the Civil War. Gatling's later model utilized the more modern rimfire cartridge, and other improvements allowed it to be adopted by the Army in 1866. This multi-barrel format would surface again many years later in high cyclic rate weapons for aircraft and anti-missile systems. Hiram Stevens Maxim was born in Maine in the United States in 1840. At age 14, he became an apprentice coach builder. He eventually went to work for his uncle in a machine works where he became a draftsman and instrument maker. He was also an inventor, having created the mousetrap and made several designs for aircraft and even a counter-rotating helicopter design. He also lays claim to inventing the electric light globe and installed electric lighting into the Equity Insurance Company building in New York, and took out numerous patents for both light globe designs and manufacturing methods for light globe components. Thomas Edison disputed several of these patents, and due to a better understanding of patent law, had one of Maxim's patents cancelled on a technicality, enabling Edison to manufacture the incandescent bulb under his own name. In 1881, fed up with Edison, he migrated to England, where he applied his inventiveness to arms manufacturing, and from 1883 patented several methods for an automatic fire mechanism, gas, recoil and blowback methods of operation for a self-loading weapon. The machine gun was born. Unlike the Gatling hand crank system, the Maxim gun utilized the recoil energy of the gun to actuate the mechanism, ejecting the spent round and loading a fresh round from a belt threaded with rounds. The Maxim could fire up to 600 rounds per minute and be operated by one man. However, it usually required a team of men to position the gun and keep it water-cooled and fed sufficient quantities of ammunition. Maxim established the Maxim Gun Company, which was financed by the son of steel entrepreneur Edward Vickers, Albert. Later, the company would join with a Swedish competitor, Nordenfelt, and become Maxim Nordenfelt. Finally, the company was absorbed by its parent company, Vickers, to become Maxim Vickers. A prototype version of the Maxim gun was taken to Africa by the Emin Pasha Relief Expedition of 1886 in an attempt to relieve General Gordon. Later, it was taken up by British colonials in Singapore and was used in the First Matabele War of 1893-1894. In one battle, 50 soldiers with 4 Maxim guns held off 5,000 enemy warriors. The gun helped in the rapid colonization of Africa by European powers. Military forces were reluctant to adopt the new weapon at first. Their main criticism was that the gun generated too much smoke, which gave away its position too readily. A legitimate concern that was soon remedied by the invention of smokeless gunpowder. Several people developed smokeless powders of various compositions. Paul Vieille in 1884 developed poudre B, a derivative of gun cotton. It was very effective in small arms and still worked when wet, unlike black powder. In Britain, Alfred Nobel, the creator of dynamite, developed ballistite in 1887. It was modified by Frederick Abel and James Dewar and eventually was called cordite. This led to a legal feud with Nobel over patent rights. In the USA, however, it was none other than Maxim's brother Hudson Maxim who in 1890 patented smokeless powder in the USA. With the smoke problem ironed out, 120 Maxims were ordered for the British Army in 1888. They were to be chambered for the same ammunition that was currently in use with the Henry Martini rifle 5.77-450. A sort of arms race ensued as European armies armed themselves with this new weapon, and arms manufacturers went to work on their own machine guns. The Maxim found its first significant action in the Russo-Japanese War. In fact, half of all casualties from that conflict were attributed to the weapon. The race was on to improve this type of weapon, and several redesigns and clones appeared. Another machine gun design patented back in 1870, the Swedish Kjellman machine gun, also suffered the smoke issue and was resurrected with smokeless powder in 1907. But it was very expensive to manufacture and only 10 were ever produced. It had a breech-locking mechanism similar to the more successful Russian DP-28. Albert Vickers purchased the company outright in 1896 and took the Maxim design and made several improvements, including adding a muzzle booster and reducing its weight. The Vickers gun was formally adopted by the British Army in 1912, using it alongside the Maxim gun. Chambered for .303, the same as the current rifle ammunition, the gun became very popular with the soldiers as it was highly effective, foolproof, and very rarely malfunctioned. During the First World War, it became the principal machine gun for the British forces. The German Army's main machine gun of World War I was the Maschinengewehr 08, an almost direct copy of Maxim's design. Based on the licensed copy model 01, it had a cyclic rate of 400 rounds per minute, using a 250-round fabric belt. It was produced at DWM in Berlin and at the government arsenal at Spandau, hence its adoptive name of the Spandau MG08. The later model, the 0815, was lighter, had a pistol grip and bipod. An air-cooled variant was used on aircraft of the time. During the First World War, manufacturers were outputting 14,400 machine guns a month. Another medium machine gun designed by German Andreas Wilhelm Schwarzlose was a much simpler mechanism than the Maxim, but looked very much like one. Adopted by the Austro-Hungarian army, it had a cyclic rate of 400 rounds per minute. It was a toggle-delayed blowback type, and the entire mechanism relied on only one recoil spring. And when this was replaced with a stiffer spring, cyclic rates of 580 rounds were achievable. It also incorporated a device that oiled cartridges as they were chambered to help ease extraction. It was never as popular as the Maxim. Designed as a squad automatic weapon, it suffered from inappropriate use. It did, however, see service in the Dutch, Greek and Hungarian armies in the Second World War. The French Hotchkiss M1909 was adopted by that country in 1909. Designed by American Benjamin Hotchkiss, it was a gas-operated, air-cooled gun fed by either a strip or, in later models, belt-fed. The US adopted the weapon with a bipod mounting in their .30.06 caliber. The British had a .303 version. In 1911, US Army Colonel Isaac Newton Lewis took the work of Samuel McLean and developed the Lewis gun. It weighed only 12.7 kilograms and had a cyclic rate of fire of 550 rounds per minute. It was most notable for its large barrel shroud and circular top-mounted magazine. Lewis, unable to interest the US armed forces, moved to Belgium, and in late 1913 his design, adapted to the British .303 round, was adopted by the Belgian forces. In 1913, Britain followed suit. The light weight and ease of use of the Lewis gun made it ideal as a squad automatic weapon. Although the Americans did not adopt the weapon at first, the British employed them in large numbers along the Western Front of World War I. A gas blowback type, the gun tapped off gas from the barrel, which drove a piston back, which was attached with a helical cam to the bolt. It utilized a 47-round magazine. The light weight of the Lewis made it ideal for use on aircraft, and it had a 97-round circular magazine. It was also chambered for the American .30-06. As the Lewis was adopted by the British and Commonwealth soldiers, The Vickers was re-identified as a heavy machine gun and put in the hands of a special machine gun corps. The Lewis was also mounted on the Mark IV tank. John Browning had tried to interest the US Ordnance Department in his heavy machine gun design, but could generate little enthusiasm. But after war was declared in 1917, he was granted a demonstration. In one such demonstration, Browning fired his gun in 2 lengthy bursts of 20,000 rounds without a jam or misfire. It was after another demonstration, where he fired the gun for 48 minutes non-stop, that the Army finally adopted the gun as their heavy machine gun. The Browning automatic rifle, or BAR-M 1918, used a large .3006 cal round with a 20-round box magazine. Gas-operated, air-cooled, operated with an open bolt design, the original model had selective fire capability. It saw action in both world wars and, under license, was manufactured in various countries with local modifications, including pistol grips, caliber and bipod design. Designated a machine rifle and intended to be used on the move for suppressing fire, it was heavy and difficult to maintain. Several variants were issued to US forces, including a 40-round magazine for anti-aircraft use. Post-war, the BAR was a popular weapon. Infamous gangster Clyde Barrow used a short barrel version he had stolen from the National Guard. In 1921, the Czechoslovakian army went in search of a light machine gun. They found a design they liked in the Praha I-23. It was a magazine-fed version of an earlier belt-fed design by 2 brothers, Václav and Emanuel Holek. The weapon was built at Česká zbrojovka, CZ, but their capacity was limited, and the army had the design copied at a much larger arms manufacturer in Brno. This was the cause of a long court battle over royalties, but the ZB-26 model became a very successful design. In various calibers, it was sold to over 24 nations. Later improved models, the ZB-30 and ZB-33, were to fare just as well. When Germany took over Czechoslovakia, they too adopted this design, which saw service with the Waffen-SS. The ZB-33 model would finally become the British Bren gun in .303 caliber and later in NATO 7.62 caliber. It was an air-cooled, gas-operated selective fire machine gun. Fed with a familiar overhead magazine, the British Bren version was chambered for .303, which required a curved box magazine. It had an integral bipod, and the rear sight was offset to compensate for the magazine. It saw service with British and Commonwealth forces in many fields of combat for over 40 years. The Japanese Type 96 light machine gun was also derived from the ZB design. Primarily designed by Heinrich Vollmer from Mauser, the Maschinengewehr MG34 was based on the earlier Solothurn 1930 MG30 that was being introduced to Switzerland. It differed in the barrel shroud and feed mechanism. It was an air-cooled belt or magazine-fed machine gun chambered for a 7.92 by 57 mm Mauser round. There were 2 versions, the light roll, which was fitted with a small bipod and a 50-round belt housed in a drum-shaped magazine, and the heavier variant, fitted with a larger tripod and belt-fed. In practice, however, troops preferred the bipod version with the belt feed. Adopted by the German Army in 1934, it saw service throughout World War II. It was intended to be replaced with the 1942 model, but manufacturing was slow to replace the model. There were several variants, including an increased rate of fire up to 1,200 rounds per minute. Introduced in 1942, the Maschinengewehr MG42 maintained the same high rate of fire as the MG34 variant and was known as the fastest single-barrel machine gun design. A roller-locked recoil operated with gas assist mechanism, it could fire between 900 and 1,500 rounds per minute, depending on the bolt. Simple in design, reliable and durable, this was a popular weapon with a distinctive muzzle report. It was renowned for its suppressing power. Its design lineage continues on to this day in later models, the MG2, MG3, the SIG 710-3, MG42-59, and Spanish Amelie machine gun. Many design elements can also be found in the American M60 machine gun. The US forces looked for a new machine gun after the Second World War, and took many elements of the German-designed MG42, the Browning M1919 and the BAR, which it would replace. The resulting design incorporated a gas-operated open-bolt weapon and, fed by a disintegrating metal link belt, it was chambered for the NATO 7.62 ammunition. The M60 saw extensive use in Vietnam and later conflicts. It was able to be fired from the shoulder or its fixed bipod. Best accuracy was attainable when used when vehicle-mounted or on a tripod base. Several variants were developed over its lifespan. Only recently has it been superseded by the FN Mag 58 redesignated the M240 family of weapons. The M240 is another belt-fed, gas-operated medium machine gun in NATO's 7.62 caliber. It is a heavier weapon, but popular for its reliability. It comes in several variants and is a popular vehicle-mounted weapon. Necessity being the mother of invention, soldiers fighting in the trenches of the Western Front sought a new weapon to assist in trench clearing. A firearm with a high rate of automatic fire, but small, light and easily manageable. Although the Italian-designed Villar-Perosa was categorized as a submachine gun and fired 9mm ammunition, in 1915 its application was as a standard machine gun. Attempts were made by the Germans to develop the Luger and the Mauser pistols into a fully automatic weapon with the requisite rate of fire, but with little success. The weapons were too light and hard to control. They sought a different solution by designing a weapon from the ground up. The first practical submachine gun was the MP-18 Mark I. Manufactured by Theodor Bergmann, it was co-designed by Hugo Schmeisser and introduced in 1918 to the German army. It retained some components of the Luger pistol, the same 9mm ammunition, and although a box magazine was designed for the gun, it was adapted to use the Luger's 32-round snail drum magazine. This new type of weapon design led to a plethora of copycat and modified designs. The Italian Villar-Perosa was modified in 1918 to become a true submachine gun. American General John T. Thompson saw the potential of this type of weapon for trench and close quarters fighting, and set about designing an American variant with the requirements of being operated by one man, light, a high rate of fire, utilizing a rifle caliber round. He set up a company, the Auto Ordnance Corporation, and employed several designers. In his research, Thompson found a patent design by one John Bell Blish. The Blish lock functioned on the scientific principle that dissimilar metals under pressure manifest differing static friction tendencies. In layman's terms, metals of differing types stuck together longer under pressure than like metals. Thompson soon found only one type of ammunition currently in use with the US Army functioned correctly with the Blish lock. That was the .45 ACP pistol cartridge. By 1918, Thompson had ironed out the bugs of the design, but with the end of the war it never saw service in the First World War. The gun, however, found outlets in several other countries, including China and several police forces. It was a popular firearm amongst the general population, particularly the gangster elements of Prohibition America. The Tommy gun shot its way into popular culture. Light, easy to use, and with a high rate of fire, it came with a drum magazine of 50 or 100 rounds, or a box magazine of 20 or 30 rounds. The 1928 model was adopted by the US military. In 1938, a variant M1A1 with minor modifications was adopted by the Army. With the outbreak of World War II, the gun proliferated amongst Allied forces, particularly in the Pacific field. It was popular for its size and rate of fire in the jungle environment, although the ammunition was not as penetrative as a rifle bullet. Newly developed special forces and paratroopers also utilized the gun. Variants were used by the Swedish and Soviet armies. The Thompson SMG saw service through World War II, Korea, and into the Vietnam War. Some paramilitary and guerrilla forces still use the weapon today. The gun was withdrawn from US military service and replaced with the M3 submachine gun and the M1-M2 carbine in 1942. The American M3, or grease gun for its similar appearance, was chambered in .45 ACP and 9mm for use with British OSS forces utilizing the Sten magazine. A modified version M3A1 with several modifications also saw service. The MP40, often mistakenly called the Schmeisser after weapons designer Hugo Schmeisser, who only had a patent on the magazine design, was developed from several earlier models, the MP36 and MP38. Chambered for 9mm, it had a cyclic rate of 500 rounds per minute, quite high for a submachine gun, and part of the reason for its popularity. It was used extensively by Nazi forces during the Second World War. The Finnish Suomi KP-31, an original design by several Finnish army officers, proved to be the most successful of all World War II submachine gun designs, and was copied by the Soviets for their Model 41 submachine gun. The British Army had purchased the Thompson, but could not get enough. After the Dunkirk evacuation, many were lost. The British, fearing impending invasion, needed a quick-to-manufacture, cheap automatic weapon to equip their forces. The small arms factory at Enfield set about designing such a weapon. The Sten gun in 9mm was created. Its Spartan appearance belies the efficiency of construction. With only 47 parts, it could be manufactured in 5 man-hours from stamped components and spot welding. An open-bolt blowback mechanism, it utilized the exact same magazine as the German MP40 submachine gun, although it was placed to the side of the breech, giving it the distinct design. Easy to disassemble and hide, it was a popular weapon with resistance and special forces. The design was licensed in several countries, including Australia, who developed the Austin variant. Over 4 million were manufactured. Towards the end of the war, Germany, short of material and time, manufactured a cheap copy of the Sten. The MP 3008 differed only in the magazine position. Cheaper and quicker to manufacture than the MP40, fewer than 10,000 were made. The Sten was replaced by the Sterling SMG, also in 9mm. It saw service up to 1988 and was phased out for the standard British assault rifle, the L85A1. The only Australian-originated firearm of World War II was the Owen SMG. Originally designed in .22 caliber, the design was rejected by the military. After hostilities began in World War II, Owen redesigned the gun in 45, 38 and 9mm calibers, and eventually won approval for the 9mm version. Similar to the Sten gun, but with the distinctive magazine on top of the receiver, the gun was able to keep operating even after submersion in mud and sand. It was later replaced by the F1 submachine gun, similar to the British Sterling except for the top-mounted box magazine. It too succumbed to the assault rifle design and was replaced by the Oster. Pressed by a devastating war with Germany, the Soviets developed their own weapon, the PPSH-41. Soviet forces also required a class of weapon for close-quarter fighting in urban and forest environments, one that could be manufactured quickly and cheaply. The PPSH-41 was a cheaper, easier-to-manufacture variant of the earlier PPD-40. Based on the 7.62 by 25mm pistol round, it too was a simple blowback operation with a box or drum magazine. It was a durable and low-maintenance weapon, and over 6 million were manufactured. Each was made in only 7.3 man-hours. The Beretta MEB-38 and its derivatives up to the modern Model 12 was the Italian submachine gun of World War II. Developed by the Germans in 1944, the STG-44 Sturmgewehr 44, also known as the MP-43 and MP-44, took the experience of the submachine gun with a high rate of automatic fire, large capacity magazine, but with the accuracy and capability of a rifle. The Germans had deduced that most firefights occurred within 2 to 30 meters, and therefore developed a cut-down or shortened rifle cartridge round. The result was a new class of firearm, the assault rifle. In 1938, Mikhail Kalashnikov was drafted into the Red Army. He served as a tank driver mechanic and saw action with the 24th Tank Regiment in Stryj and Brody. He was wounded at the Battle of Bryansk and spent 6 months recuperating. He spent his time designing a submachine gun. The design was rejected, but authorities took notice of this young designer and put him to work at the Central Scientific Development Directorate from 1942 on. There, he designed a gas-operated carbine utilizing the new 7.62 by 39mm cartridge. His design was heavily influenced by the Garand M1 design. He eventually gained success with his MiG-Team prototype. This development led to his design of the 1947 model Automat Kalashnikova Model 47, or more commonly referred to the AK-47, his most famous of many inventions. The AK-47 quickly became the Soviet Union's standard issue rifle. It came in two variants, the fixed wooden stock and the AKS-47 with a metal folding stock. It is readily identifiable for the long curved box magazine and distinctive foresight. Becoming the chief designer, he quickly developed a squad automatic variant known as the RPK and the PK, which utilized the full-size Nagant rifle cartridge and was belt-fed. Designed to be easily stamp manufactured, the weapon found service in many armies of the Soviet bloc. In 1952, a modification to the design was made. It had a milled receiver, barrel and chamber were chrome-plated to reduce corrosion, but retained the same ammunition. In 1959, another variant was introduced to Soviet forces, the AKM. It was optimized for mass production. A compensator was added to the barrel to alleviate rapid-fire climb, and the forestock was grooved. The hammer mechanism was also overhauled, and many improvements added. There are numerous variants with illuminated sights, folding stock, and facility for night sights. In 1974, another major overhaul of the design was introduced to military forces. The AK-74 was rechambered for the new 5.45mm ammunition. This model was adopted by several other nations, and the Chinese developed their own variants based on the AK-47 model. The AKS-74U was the more extreme variant used by special forces. This model of weapon has had extensive use throughout the world. It is a reliable and easy-to-use weapon that has become synonymous with communist forces and later the international terrorist.
Ни один автомат участвует в боевых действиях. Слишком много разнородного оружия участвует в современных боях. Поэтому нельзя ничего сказать, какое он, так сказать, отношение или по сравнению с другим оружием. Я не могу сказать, потому что масса различного вооружения применяется в современных боях, боевых действиях. Вот что я могу сказать.
Newer models have been developed. The AK-101 chambered for the NATO 5.56 round, and components are made of plastic rather than wood. Aimed at Western clients, it is accurate and legendarily reliable. The AK-103 sports the same lightweight improvements, but includes the ability to be accessorized with various sights and a grenade launcher. The AK family of weapons continue to adapt and improve till this day. The US military sought a new weapon designed around the smaller 5.56 caliber munitions. They called upon Stoner's assistant and technical drafter to rework the basic AR-10 design and created the AR-15 assault rifle. It was adopted by US forces in 1966 as the M16 rifle. This iconic weapon in various configurations was adopted by many of the US allies as their standard infantry weapon. Design adjustments from experience in the field evolved the model to the M16A1 and A2 variants. Stoner, disturbed by reliability complaints of his direct gas weapon design, set about a new design in the AR-16, a traditional gas pushrod configuration. After being rechambered for the .223 round, it was adopted as the AR-18 rifle. Stoner went on to work with other companies developing several weapons systems. Of particular note was the Stoner 62 weapon system, a gun capable of being adjusted to fit various roles from automatic rifle to light to medium machine gun to a fixed vehicle-mounted remotely fired system. He went on to design the Ares light machine gun and the FARC, or Future Assault Rifle concept. Today, the US forces maintain the M16 in various configurations, including the M4 model. As for the future of the modern infantry weapon, some paths have already been taken. Numerous countries are adopting the bullpup design concept, placing the breech and receiver behind the trigger housing, resulting in a much shorter weapon but retaining the barrel length. This type of weapon is seeing service in several military organizations. The Steyr AUG, French FAMAS, and the H&K SA-80 models are particularly successful design. Other advances are with optical and electronic sighting systems. Fitted with underslung grenade launchers, high-capacity magazines and night vision, these machines of war have taken the simple infantryman and given him the firepower and capability undreamt of in earlier times.